ICT Academy, Mr. Altaf Hussain Khanday. He is going to give you an interesting session in the topic of generative design workflow using Fusion 360. As we are all aware about that, Fusion 360 is the first cloud-based CAD tool which integrates all the aspects of design, manufacturing, and simulation. So this particular session really useful for all of us and design thirst oriented engineers. Definitely you will have a wonderful session for this particular topic like Fusion 360, and he is the right person to deliver this particular topic because his area of expertise also the same for last 6 years. And going forward, I request Dr. A. Sangeeta, professor from Department of Mechanical Engineering, I request to give a brief introduction about the today's speaker to the participants.
Yes, sir. Thank you, sir.
Sangeeta ma'am, just a minute, ma'am. Sangeeta ma'am. Ma'am, yes. Rajesh Kannan sir is not switch off the screen sharing, ma'am. Rajesh Kannan
yes.
sir.
Yes, sir. I will.
Please stop.
Yes. Thank you.
Yeah. Just stop the share only, sir. No problem. Just here, sir. Stop. Okay, sir. Right, sir. Thank you, sir.
Thank you, sir. Thank you, sir.
Continue now.
Okay. It's my great pleasure to introduce Mr. Altaf Hussain, an accomplished design trainer with a robust 6-year track record in training and development. He currently serves as a senior design trainer at ICT Academy, a role he has held since November 2021. In this capacity, he imparts advanced technical skills and inspires creativity in design across a global network of learners and professionals. Prior to this, he gained practical industry experience. He began his professional journey as a CAD engineer at CAD Center Training and Services, serving from 2018 to 2019. Following that, he worked as a business advisor corporate at India Filings Private Limited from May 2020 through March 2021, a role that broadened his understanding of corporate dynamics and client engagement. Also, his educational background perfectly complements his career trajectory. He holds a BE in Aeronautical Engineering and postgraduate certificate diploma in aerospace design credentials that reinforce both his technical proficiency and his ability to approach design from an analytical systems-oriented perspective. His technical fluency is extensive. He has mastered a wide suite of product design tools, including CATIA, Creo, NXCAD, SolidWorks, and Fusion 360. On the analysis front, he is proficient with ANSYS Fluent, FD, LS Dyna, and he is well versed in architectural tools like Revit, along with AutoCAD, MS Office, and Primavera. His credentials are further strengthened by an impressive array of certifications. He is an Autodesk certified instructor, as well as a certified user in Fusion 360, AutoCAD, and Revit. In addition, he holds advanced certifications in CATIA and SolidWorks, and is certified in enterprise design thinking and enterprise co-creator programs from IBM. In total, Mr. Altaf Hussain represents a dynamic blend of technical mastery, instructional excellence, and cross-vector versatility. His journey from CAD engineering and business advisory roles to leading design training at ICT Academy exemplifies a rare fusion of design acumen and impactful pedagogy. We are honored to welcome to our FDP today, and we look forward to the insights he will share with us. Over to you, sir. Sir.
Altaf, sir.
Thank you for the wonderful introduction. I hope I am audible.
Yes, sir. Yes, sir.
Yeah. Okay. I once again thank you for this introduction. So, good evening, everyone. Good evening, I am glad to be part of this wonderful FDP, and I truly appreciate the organizers for arranging such a wonderful platform. I actually was waiting for this since from 1 hour. So actually, I got lots of insights related to material selection and lightweight materials from the Dr. Rajesh Kannan. So it was really great, I think, for opportunity for me also to learn something new about the materials. So now I will be sharing, I don't want to waste your time. I will be sharing insights on generative design workflow in Fusion 360. So it's a more technical. So I will show you how we can create different designs, number of, no, I can say thousands of designs by using AI or by using generative design in Fusion 360, because it is the, it's the age of AI. So how we are using AI in the generative design, how we can create design by using generative design. So everything I will be covering. So I will share my presentation. So before going to the software, I will just show some slides to you so that we can get to know what are the things that I will cover during this session. Let me give me a minute. I will share my presentation. One more thing, as I am from the Kashmir, so I am facing here some internet issue. Maybe in between, if I face any technical issue, kindly let me know that, because I am residing in in a hilly area. So here I am facing some technical issue in internet, I can say.
Sure, sir. Sure, sir.
Yes, yes, yes.
Okay, so I will just share my screen.
Okay, sir.
A minute. I hope my screen is visible.
Sir, your screen is visible, sir. Visible, sir.
Yeah. Okay. So as you have heard all about the lightweight materials, you have seen how topology optimization works, how the industry are taking these things, how they are saving different things by using topology optimization or generative design or composite materials. So everything you have heard in the session. So now I will go technical part. I will show you how we can do in practically, how we can do in this in the software itself, so that we can get to know how we can create a design from different approach or from different way of thinking. Suppose we have some idea, we have some from nature, I can say from nature we have some ideas, so we want to create a same kind of designs. So how can we do that? So I will be showing you in this session how we can show, how we can create a generative design that looks exactly, I cannot say exactly to nature, but we can mimic to the nature. So like we have seen the bones, we have seen leaves. So we are following the nature, and we are creating the, we are just mimic the nature and creating designs. Same way I will be showing you today how we can do in the software in Fusion 360. Okay, so my slide, before going to software, I will give some slides, some presentation about some topics. So my agenda for this session is, I have some topics to discuss. First, I will be discussing about the generative design. Why generative design? What is generative design? So I will just go deep inside to generative design. I will uh, explain you why it is important, why it is the age of generative design. Okay, so then after then I will talk about brackets. Maybe you have heard about the brackets. So if you are going to general design, you are learning general design, you may heard about the brackets. Maybe whenever you are going, whenever surfing or searching about a general design, you will see about, you will heard about, you will hear about brackets. So I will just talk about that thing also. What is the brackets? What is the story of the brackets? Right? How the generative design comes to play in the role. So all the things are the story about the brackets. I will be telling you that also, because that's very important. With that, we got idea that generative design is very important in the industries, right? So that topic, that is my some this topic I will be discussing also. And uh, then I will go to the software and I will show you practically how we can create, what are the things, what are the steps to follow to create a generative design, right? So that thing I will show you in the Fusion 360, Autodesk Fusion 360. Not 360, it was before Fusion 360. Now it's Autodesk Fusion because they have removed the 360. Now it's called only Autodesk Fusion. So, and also I will be talking about generative design and additive manufacturing. So why they are called soulmates, right? So I will just explain you why generative design and additive manufacturing are soulmates. So this thing I will also cover. So you will get to know when I will uh, come to the topic, and you will see how the generative design and additive manufacturing are working together, and how they without additive manufacturing or without generative design, we cannot we can do things but not that level. But if you see generative design and additive manufacturing, so you will relate things. You will see, okay, it's very easy now to create designs that are mimics to the nature by using additive manufacturing when we have done those things in the generative design, when we have created those things by using generative design, right? So that that point also I will be discussing. And now the actually course that I want to cover. So this was actually some points I want to discuss. Uh, so extra I can say, but the session highlight, that I can say the session that I wanted to cover to you, these are this session. So first I will be talking about the generative design. Second, I will be comparing generative design and topology optimization or shape simulation, how we can do those things in the Fusion 360, how the shape optimization was working, or still it's working, but now it is the age of the generative design. So how we can compare those things, what is it, shape optimization and what is generative design. That things these things I will show you practically to you, so that you will get to know how we can do in how we can do in these things now, any software, not only Fusion. So you will get to know that practically, right? So I will be coming up this topic also. Then third thing, I will show you generative workflow stages. So what are the steps? What are the process, or what are the workflow in the Fusion 360? How we have to set some conditions to the software, some constraint to the software, some inputs. How we have to give some inputs to the software, so that software will give us solutions, right? And we can get, then we can select the novel solution, and we can select the what exactly we need, and then we can work on that, and we will get the required design, right? So that thing I will show you how we have to see how what steps we have to follow to create a final design. That workflow, that stage I will be showing you practically in Fusion 360. After then, we will be seeing generative design. Practically, we will do some design, some case study. We will use those steps to that particular design, and we will see the outcome, and we will explore the outcome and see the different things, what are the different solutions that software will give us, and we will compare them, and we will see how useful, how important, how I can say solution given by the software is. So we can check that, we can analyze that. So those things we will see the practically, so that I will explore those results after doing the all the steps, or after following the all the steps, we will go to that one. Okay, so these are the some topics that I will cover. I know practically it will take much time when we go to practical part. So it takes much time. So I will try to cover all the topics, so that you will learn, you will do practically things in the software, as Fusion is very economical, and it's easy to use. You can download or you can install by creating education account, and you can then do the different things in the Fusion software. Fine. So now I will now come to the topic, first topic, that is generative design. In generative design itself, I have some points to discuss. So first, I will be discussing about generative design, then the evolution of from traditional CAD to AI-driven design. AI-driven design means generative design nowadays that we are doing. So what is the evolution from how we have done these things? So I will talk about this thing also. Then uh, topology optimization and generative design. So this I already, and also why industries are adopting it. So these are in this particular topic. Now I will go one by one. So first thing, whenever you are seeing the generative design, it's actually advanced, advanced part in the Fusion 360. Not advanced, but for us it's advanced because we need to learn. We need to see how we can use our ideas, how we can use our parameters, our conditions, how we can set to the software, and then software will give us solution, right? So this general design involves program. So it involves AI. So because we are giving condition to software and it is giving us solutions, right? So this we have to see what conditions we have to give to the software. That's our idea. That's what initial idea. Suppose I have some idea. I want to create some design which have a minimum mass and maximum strength or maximum stiffness. So this is my idea. That is what I want from the software. So I will give this idea to software and I will apply some condition to the software, and then software will do the process and it will give us solutions, right? So this is the like AI. So you will add it to the software and software gives the solutions, right? So these are generative design. And also, it will not give only one solution. It will give us thousands of solutions. So that means we can compare then. If it gives us many solutions and we can select the proper one and see, and we can work on that and we can then get a required design, right? So that's what generative design is. And initial data we will give some idea or parameters, some conditions to software. So we have an algorithm in the software, right? And so software will work on that and it will give a solution. So we will check the solutions, solution 1, solution 2, or solution n type of solutions. So once we will get solutions, after then we will just judge the output. What software will give us, we will just judge the output and we will see, okay, do we need some modification or do we need some change on that solution? So we will just do some modification on that. Then again we will do some fine tune on that particular design or particular solution. Again we will use the software and we will work on that and get a required design. So this is the thing that general design follows. That's how we create design, and we give idea and software works and we get a design, right? So and one more thing, and also this general design, as I told, is an AI driven approach. So we are giving some conditions to software and it will give us a solution. Before, what we were doing, we were just first design and then we were testing, right? So we will create a design, we'll manually do that, and after then we will test that. So it was like a time consuming, right? But now what generative design have done, so we are defining, we are just giving a conditions to software and it is giving different solution to us. So we are just simply exploring the designs, solutions or outcomes of the design. So it have saved us time. It have saved our it has even it gives us idea what is good for you, what design will be suitable for you, because it gives us different things to us. So we can then explore our outcomes and we can select the proper one, right? So now this generative design have changed it. Like first we were designing and then we were testing. Now we don't do that. We just define and it will give us solution and then we will explore those solutions. Okay. And not only one solution, as I told you, it will give hundreds of solutions, possible solutions, and then we can compare them and we can get a normal solution. And one more thing in generative design, it is main important thing. The generative design is like we get lighter design and but that will be more stronger, right? And which will be ready for the manufacturing, like for 3D printing or additive manufacturing. So it gives us that kind of solutions. So this is a generative design. I hope you got some idea regarding that. So I will then go deep. I will now go deep to that. You can see the process, how it works. Then I will go practically. As I told, is AI powered initiative. I know AI powered. So it will do different iterations, to create a better, to create a possible solutions, right? Create after then, you can just, and all, not only solution, the solution will be like, it will mimic to the nature, because nature is a is a best designer. So we always mimic nature. So we see what nature is. So we try to create that kind of design, because that is um, uh, that's actually novel solution. Whenever we try to design, we always mimic nature. You can see wherever you have seen designs, you will see some related to the nature, right? So nature is the best designer. Same way, generative design mimics the nature and create a novel solution. Um, so and if I go to the, I will just go practically that one. I will show you when you see the designs, and you will see, compare, and you will see different things in the solutions, and you will get to know how generative design is and how important this generative design is, and how the industries, why the industries are following this generative design. Okay, I will give some example to that. If you see this picture or this slide, you will see here, here's a bracket, seat bracket, right? So in this one bracket, you will see we have a, different parts. That's this one is a traditional one, that how we create. We create parts, we create design, then we will assemble them, right? So this is traditional one we created. And then you will see this one. This one is, by using generative design. If you see here, if you just look at this design, this one is made up different parts or different components. This one is made up of, a single component, right? So here what happened, it have saved us time. And also, if you see here, this particular design of, see this seat bracket is 40% lighter than this one, and 20% stronger to this one, right? So that means generative design is very, very useful. That's why industries are following it, because it is, every, wherever you see, whether you see the aerospace, so they are working on, they want to create such kind of components or such kind of products where they have a lighter, they have a, I can say, lightweight, and but that should be, more stronger. So generative design works for that. So you can see this seat bracket is 40% lighter and 20% stronger. And second thing, you can see here we have created 8 components, but in this generative design we have created 1. So that means this one is very, very, useful. And also, if I then go to this one, you can see I will go one example to. Okay, later on I will go to case study, because of the bracket, uh, seed bracket, that was a G bracket. So I will go to that. I will just show you how much it has saved to the aviation industry, uh, how much fuel or how much money it have saved by creating single this bracket, G bracket. I will show you that one later on. You can see here, as I told you, 8 components were made by traditional. So that's how we do use the software and create a parts in solid workspace, and then assemble them, and then go for a manufacturing unit and create the full final product. But in generative design, it will create singular product, and this will go to the additive manufacturing, and we can get a final product, right? So, and it's a 40% lighter, 20% stronger. So we don't compromise with the strength of our of our product, right? So the AI, I can say the generative design, works on that particular thing. As I told, there will be different solutions from out of different outcomes. We can get a novel solution. We can work on that. We can, if we want to do some modification that, we can do that. And after then, we can go for the additive of, I can say, create form tools, or we can create a from organic structure. We can create some mesh designs, and then we will use that particular design to the additive manufacturing and create a final product. So I will show you that in practically those things, how we can do that. So you can see for this particular solution, for particular component or this design, so we got different solution. There were different solution for this one, and from among them we selected one that was a better one, right? Okay, so now you can see, I will just go quickly to this one because it's more practical. uh, if you see evolution of this design tool to traditional CAD, what we were doing, we were just using the geometry and we were manually creating sketches and then create a design, right? Then we were testing on that design. So after then, we got topology optimization that removes unnecessary material. I will show you that thing also in the software, Fusion software. So how we can remove the material, how it works, right? But it is I can say more time consuming than the generative design. But it's very good. Actually, we are still using this shape optimization. We are still working. Even industries are still using this one, but now they are trying to use generative design. But mostly they are using this shape optimization process to create a final product. So now we have a generative design. So it creates thousands of solutions, and it saves us time. So this is age of the generative design, right? So what is the evolution of this design? I guess design from drawing geometry to defining intent. So we are simply giving, before we are drawing the designs, no, we are giving some conditions, and AI do that part for us, right? So this is the thing. Timeline chart, you can see from 90s it was CAD. We were mostly doing the drafting and creating the design, and then we have simulation comes to 20s, 20, right? So in simulation we analyze, we do different shape optimization, we do other things. So there are lots of things in simulation, and then comes the shape optimization. So it is still going on, but now the industries are following the generative design. Okay, so it is the age, I told, is the age of AI, so it's the age of generative design. So you can see, I will just compare, I will go now to the software. I will compare first optimization, shape optimization and generative design. So in shape design, what you will do, you will create a design. That's how you manually create a design. After that, you will go for the analyzing to that design. Okay, so you will analyze that, you will apply some conditions to that design, and then you will get shape optimized design, and you will then modify that one and create a better one, right? So it is like a single solution you will get from a single design. Okay, so this is the thing you will do manually by one. You have to do all the process. You have to follow all the process. So like this way, you will get a final design by using topology optimization. But if we go to generative design, as I told you, we will simply give the some conditions to that, right? And we will get a solution, and then we can modify that and create a novel solution. So I will go practical this one. I will open the software. I will show you first how we can do the shape optimization, because it's still going on. It's industry still use this method. So they still use this technology. Um, because for the generative design, there are some challenges also. So I will be talking that later on also, because we mostly use additive manufacturing for that one. For the traditional manufacturing, we use milling, or we use other casting process. But for the generative design, we mostly use additive manufacturing. So there are these challenges there. That's why some industries still follow this shape optimization. Okay, let me now go to the software. I will just show you practically how we can do these things in the Fusion. Just a minute. I need to share it once again. Okay, so this is a software. I hope everyone have this this software. If not, as this is, I told it's economical software. I know it's free for students or for faculties. So you can just create an account from Autodesk, and you can use this software. It's very important, and you can do different things by using the software, Autodesk Fusion software. So you can see I want to show you some first shape optimization. Then I want to compare this shape optimization with the general design. For that, let me create a quickly one design. I will just try to create one. Let me create from here only. So I will select this reference plan and go for the sketch. Let me create some circle. I will create some wheel. So on that wheel, I will just do the shape optimization, and we will see how the final results we will get from the shape optimization, right? I will create circle, then one more circle of diameter. Let me give it. And one more thing before going to this one, okay, millimeter, I kept the units millimeter. This I will give 25 mm. And for this one, let me give it 500. Okay. So I will create here one part. Let me create one line from here, one part of this wheel. Make it horizontal, give some constraints. Fine. I will give also angle to this one. I will define this one. Let me delete first this one. Dimension. Actually, it's auto, so I need to change. Let me delete this one. Because it's already I have already applied a constraint this one. So once you are applying to it will be over constraint. So I hope you have you have used the software, Fusion software. So these things you can just delete if it happens. So it becomes over constraint. So you have to define it properly. Let me delete this one also. Now let's give the dimensions. $120. Okay. And I will create one more line here from here to here. And make this line horizontal. Also, I will make this line a construction line. I'm just trying to create a one part of the wheel. Okay, now I can go to solid and select extrude. I will delete first this one, this part. Otherwise, I will just extrude this one up to, let me go this one up to 50. Can get manually 50 mm. Okay, so you can see we are creating manually parts, right, for the shape optimization. I have created this component, this part. Now I will go to the shape optimization. So how I have to go? So you can go, you can switch this workspace here. We have a design workspace, then we have a design, then we have a generative design. I will come to the generative design before I will go to simulation. This here you can see this simulation workspace. If I select that simulation workspace, and you will see here we have a shape optimization. So here you will find shape optimization, right? And I will select this one and go for the create study. So I am now in the shape optimizing workspace. So here also we have to follow some conditions. What we will do, I want to check, no, I want to analyze this particular design or this particular part. So what I will do, I will go here. Let me preserve some region. So I will show you this preserve geometry and obstacle geometry. So these two tools are very important in the general design. Here also in shape optimization, it is useful. So I want to preserve what I want to preserve this particular area, because I need, suppose I want insert here some bearing or some shaft here. So I will preserve it. I will preserve the shape of this one. I will select this area, right, and make it, let's go it, will just make it 25 radius. So this is a preserve this area, fine. And now, as I'm doing shape optimization, we are applying some conditions to this particular design, okay? And then we want to see the outcome, and we want to see the result of by using shape optimization. So now what I will apply here, load conditions on this area or on this perimeter of this wheel. So this is a perimeter of this wheel. I will just select this one and apply loads. If you see here, so I can just apply, suppose that me apply the pressure and magnitude. You can just any, suppose 10. I will get 10 value. Okay, fine. So I will just simply take select this one, and you can see I have applied some conditions this particular component. Here I have kept this one preserve, and here I applied the loads, right? And this load will be applying constant on this particular part or perimeter of this wheel. Fine. And one more thing in the shape optimization, there's one more important thing. If you see here, you can see symmetry plan, because so that there will be balance of pressure applied on this part of the wheel. So I will just apply, select this one. I will select two plans, active plans 1 and 2, so that everywhere the pressure will apply, balance pressure will apply on this particular part. Fine. Okay, so these are the things that you have to follow in the shape optimization. There are lots of tools there, but I don't want to go those, because my main topic is general design. But I want to show you because shape optimization and general designs are shape optimization is the foundation of the general design. That's why I want to show you this thing also. You can see I have done this thing. Now, if I want to go for the manage, I will divide this particular component into smaller mesh or smaller parts. As you can see, when you are using analyzing software, So we are using FEA. So we are just creating smaller parts of our component so that we can get a good result, right? Let me just decrease the mesh size and click OK. Now I will just go and solo this one. So you will get a solution here. I will just generate this one. Just a minute, it will take some time. I have created a small part, so that's why, because here otherwise it will take so much time if I just create some complex design. So in this small part, I will show you how we can create a different solutions, or how we can how we can modify the design by how we modify the outcome of this shape design. So let me just, it's not. Okay, one more thing, actually, we have missed it here, constraint. So we have at least there should be one constraint applied here. So I will go here, constraint, structural constraint. I will fix this particular area, right, and make it fix. So now I can go here, I can pre-check it whether I am, all are set. So now everything is set. So I have followed all the conditions, all the steps properly, and I will select this one, click OK, and now I can solve it here. I will get some solution. It will take just 2 or 3 minutes. Let me save it somewhere. Okay, so it will take some time, just 2 or 3 minutes, because I have just created a simple part. With that simple part, I can modify that and I can create a design. So you will get here idea how we can use different, how we can create a design from, some organic structure, or some, we have a referenced image, or some, I can say, general design. So from that, how we can modify and create a solid design, and then that solid design we can use in the, in a manufacturing unit. So just a minute, it will take just 2 or 3 minutes to complete, and we will get a solution. With this small part, we can then create some design, or I can say I can create a wheel. Okay, so till then it will take just 2 or 3 minutes. Then I will go here. I will just move to the general design until it will get completed. So I will open new workspace and keep it aside. So if you want do general design in the Fusion, so here you will see we have a workspace that's called general design, right? So in general design, if you want to create, so I will just explain you first what you have to do in the Fusion, how we can create general design. So you have to follow some steps. First one, you have to give some conditions to the I can say to the software. What kind of things you want, what kind of design criteria you are giving to the software, and what kind of solution you want, right? So those parameters you have to give, then the software will give a solution. So for that, at least I need some components so that my I will get a this software can work and it will give solution. As it will take time for me to create a design, so I have already some designs available here. I will just use them, and so that we can see how we can create a different outcomes by using general design. Otherwise, you can try here. You will get also, if you want to practice those things, you can get these things from the this data panel also. You can go here in the data panel, and then you will see, if you go down to this, and you will see here generate design samples, right? You can click on that generate design samples, and you will see here we have a different samples available in the Fusion also, so that we can use for a general design. So here is a G bracket. Actually, I wanted to talk about G bracket, but first I will just complete one here. Then I will talk you about this. What is G bracket? So how it have created, how it have created the base of the, I can say, generative design. So here I will open the G bracket. So this G bracket, actually, we are using the G bracket in the aviation industry. We are using in the jet engines, right? So this G bracket is used for that. So we are using this particular G bracket for aviation industry. So you can, I will later on talk about the G bracket also, how it have saved uh, thousands of I can say um, industries by using G, by using creating by using generative design, how they have changed the from the traditional view of design to the generative design. So by using G bracket. Okay, so this is a simple image of the G bracket. I can say only some components are there, right? So here we will be applying some load condition to that. We will be applying some parameters to that, right? And we will see how many solutions we will get after applying some conditions to this particular this body. Okay, so here we have a different things. So we have to follow one by one. First thing, you have to do you have to save this this design. As you can see, this is locked right now. G bracket, it's locked here because I have just used this diff from the sample. So I need to save it first, then I can edit this one. So I will go here. Let me first close this one. It will later on I will see this result. Okay, so I will first save the G bracket, go here, file, and then we have here save as, right? So I will save G bracket in some location. Now it is editable, so you can edit now this sample. Okay, so now I will show you how we can follow the generative design in the Fusion. So here we have a generative design workspace, right? And then you have two things or two sub workspaces in the generative design. We are going to do the statistical component. So we will go this study case and go for create study. And here you will see different tools or different things in the generative workspace that we use in Fusion. I will show you one by one how we can we have to follow. So because if we not follow properly, then we cannot get a better solution or we cannot get a better outcome, right? So we have to keep in mind, we have to follow all the steps properly, then only it can give us different outcomes with different I can say properties or different solutions that we can then compare and get a design. So you can see, okay, this one is complete. My shaped optimization is completed. So I will go this result later on. Let me first complete this one also. Okay, so you can see here you have to remember two things. One, preserve geometry and obstacle geometry. So what is preserve geometry? What things you want to preserve and what things you want to select as a obstacle geometry, right? As you can see here in this design tree or in this specification tree, you can see here preserve geometry and obstacle geometry. Preserve geometry is very important in generative design. So you have to at least one component, you have to preserve that. So what is preserve? What you have to do? Why we have to preserve? If suppose I have a this particular ring here, so in this ring I have a this I can say this shaft inside, right? So I need to save. I need to preserve this particular shape so that then I can insert this component inside to this ring, right? Or this shaft. So we have to preserve these shapes. So we don't want any change on these shapes. So that's why we have to preserve them, right? So that's if you not select these geometries or you don't want to preserve them, then it will go to deformation. So it will go changes because software will think that we have to add material here also. So it will then go for deformation. So we will get some change in these particular components also. So that's why we have to see what things we want to preserve. We have to select those components or those parts. I want save this. I want preserve this part. I don't want to see any deformation on this parts. So I will select this one and this one, right? So here we have a preserve geometry. I will select preserve geometry and select one by one that I want to preserve. I don't want to see any change on them. So this one ring and second, and this side also I will select here because I don't want to see any change by software or some deformation on this particular rings. These 4 bodies I have saved. I can save this body or this ring also because here also I have inserted this component here. So let me select this preserve also 1 and the second 4, 6. So total 6 bodies. So these 6 bodies will turn to green. That means you have preserved them. So this is a condition. So I'm just applying this condition. I want my software don't do any deformation on this particular component or particular body or particular part. I don't want to add any material on this part, or I don't want to remove on material from these parts, right? So that's what condition I'm applying to this body. Fine. And this is a preserved geometry. Now obstacle geometry. So obstacle geometry, you can see obstacle geometry actually, if you have, I will give an example like bridge. If you see the bridge, so in bridge we have a pillars, right? So they are preserved geometry. So we don't want to change on those bridges, right? We want those bridges to be same. So an obstacle geometry will be like that area where we don't want below that bridge there's area, so we don't want add material, or we don't want remove material on that particular that space or that parts. So that's obstacle geometry. So we don't want to remove or add material on those parts, right? So these are the preserve. So that's the obstacle geometry. So I will go here obstacle geometry. I will select this one and this one. So I don't want to add material on these 2 parts. So these I have selected 2 bodies. Fine. So now it will take the red color. That means when it turns red in fusion, it indicates that these are obstacle. And one more thing, as we are doing study case of this one, here we have some load conditions. We will at least one we should keep fixed. So we will go here structural constraint, and we will make fix these rings here, because otherwise if we will not make it fixed, so it will by generative design they may change the position, or they may go to some like we can see some deformation in particular this part, and here also they may relocate from other position, right? So we want them fixed, we don't want them move anywhere, right? So I will just select this one and this one. So these are the conditions that I'm giving to this particular design, and then this software will give me the solutions. This 4 I am fixing. Okay, so these are the conditions that I have given. Now these were the parameters that as I have given. Now there are other conditions also that I will give to this particular design, that are like loads. Okay, what kind of loads I will apply on the this design? What will happen if I give different loads? Suppose I want to apply loads on this ring here. I want to see what will happen and how the solution will be then showing me the result, right? So I will go here load conditions. So here's a structural load. I will select that. On these 2 rings, I will apply loads. Let me study different loads. Load case, I will use different loads so that we can then explore the different results and see what will be the if we apply some load, and we can compare then the proper design, right? So I will just select, suppose here pressure on this particular or force on this ring. Let me hide this one here first. I will hide the obstacle geometry. right? So I want to apply loads on these two rings. I will go here, design, structure loads. Let me go force, apply on this ring and this ring. Okay. So here's the condition. I will go vector 1. Let me apply 1000 or 8000 Newton on these two rings. Finish. So this is a load 1 that I applied here. If you see in this design tree here, so load 1 is here, case load 1 I have applied. After then, I will apply one more load, or I will go for a different load steady case. So I can duplicate this one here. I can right click on this load case, and here you will see clone load case. So I will make different one, then second and fourth one. Okay, so these are different load case I create here. Then I will change some magnitude of the force. So I will use, suppose for the force 1, force 2, I will use here, instead of fz x direction, I will use here 0. And for this one, I will use, let me use 7 or 800, 8000 something. If I just use minus, because in the, let me use 58500 load on this direction, and other I will keep 0. So this is a load case number 2. So I will then check also, I will explore this load case also, what happens to this particular ring. Then the load case number 3, if I go to this one again, and I will just edit this one here, loads, go to the loads, and then edit options there. I can go here and select this one. I will select, instead of 8000, let me select here 600 something, 6000 something. Okay, 6357, I will just apply for the z-axis, and this I will apply more than this 7000 some. Okay, so these are load case number 3rd and 4th one. If you try to here, okay, I will just show you. You can here we have an option to delete also. If suppose I want to delete force here in load case number 4, I want delete some force. Suppose I have force applied here, right? Force number 4. If I want to delete in the fusion, I can right click on this one and I can delete this. So force, and then I can apply manually on the rings. First ring I would apply one load, then second ring I apply other load. So here the structural loads. Let me go for the loads, this ring, and apply. Suppose let me apply mans. Okay, I'll just apply 1400. Okay, for this one. $1,400 and 1,400 for. Then for second ring also I will apply on this ring. So I'm just checking the different load conditions. I'm just giving so that you can get idea how we are giving the conditions or parameters to the generative the software, and it will give us outcomes, right? So these are the conditions that I'm providing, I'm giving to this the software. So then when I will generate, and it will give me a solution. Let me apply load on this particular also. Okay, I will now use 514 positive 1400 vector position. Okay, so now I have given conditions. If you see what are the parameters that I have applied, first I have applied the conditions. So what things I want to preserve and what things I want to obstacle, right? Then I have applied the load constraints, right? Structural loads, and also I have given conditions which thing I want fixed. So these are in load constraint that I have applied. Now, the third one, design criteria. So what are your objectives? What you want by applying such kind of conditions, and what things you want from the software to give you, right? So these are objective that you have to set. So I will go here objectives. So my objective is I am applying these loads. I want a design that should follow these loads, these conditions, or this parameters, and it will also minimize the mass, right? But the strength will be the higher. Okay, so here we have a two objectives. One, minimize mass. So you can go here and select the minimize mass. So, and second one is maximize stiffness. So if you select this one, then you have to give the safety factor also, and also what's your target mass, how much mass of you want you want the software to create a design, right? So you can give the target mass. Suppose I want 400 or something. So that's up to you what you want, what component or what body you want to create, so that the what's your target mass you will get. So you have to give that particular mass here. Then the software will work accordingly, and it will create that particular design which have that much mass, and it will show you all the properties, right? I will not go with this one. I will go, let's minimize mass, and I will give safety factor 2 and click OK. There are other things also, but I know actually I don't have that much time to go to every topic. But I will just try to see some important things that you can try also. And then once you try those things, and you will go, you will learn other things also when you do some study case to any component or any body. So here, design objectives I have done. After then, there's one more important thing, that's manufacturing objective. Okay, so we have followed some conditions. We have followed some load conditions also. Some over objective. We have set objectives also. What we want from this software. Then how we are going to create this design when software will use, when it will give us it will create a solution to us. So where we want to create a final product, whether we want additive manufacturing or we want to go for the milling or any other process, right? So we have to set that thing also here. So we will go here manufacturing, and after then you will see here we have a different options here. If you look here, additive manufacturing here. So if I want check the solutions related to additive manufacturing, I can tick that one. If you need a solution for the milling process or from a traditional process, so you can go here milling, you can just untick this one and it will give you a different solution, right? So for the additive, you can select this tick here, and for milling, or you can, if you want simultaneously different solutions by using all these manufacturing conditions, whether you want additive or milling process, so you can then tick both. So it will give us solutions for both, right? As otherwise if I just go this milling also, it will take much time to get a solution. So I will just untick this one right now. Or if you want that, so here we have a different milling axes. You can see 2.5 axes, 3 axes, 5 axes. So you can select that particular axis. Suppose I want 5 axes, I can select that one. If I want if I want to see also solution of 2.5 axes, then I can go here plus configuration and select that 2.5 axes. So it will give a solution for that one also. If I want for different axes, so you can select that particular axis and it will give you a solution for that one also. Okay, so these are the conditions you can these are the preset condition that you are giving to the software, and it will give accordingly solution, right? So right now I don't want milling, I want just additive manufacturing. So I want solution for the additive or 3D printing machine. So I will select this one and click OK. So these are the conditions that I have done. After then, the most important thing is material selection. So what are the materials that you are applying or you are setting on the design, right? So I will go here, material. So I will select that one, and you will see material library will open. So we have a materials available here. If you go here, material library, there are different materials available. fabric. So right now I want to go metal. So as you can see, for the G bracket, we can use, titanium, or we can use stainless steel. So we have a different alloy here. So we can use any material here. Let me select some material here. If I select, as for G bracket, we use mostly titanium alloy and stainless steel. There are lots of material available here, so I need to select that one. Let me check in this library whether I have selected already. I will remove this one. Okay, for the G bracket, maybe we are using aluminum or AISI 405. So let me check that one if that's available in this library. Stainless steel. Okay, so HR. Okay, this is one material that I will use here. This is 500. Let me use 490. Now for the GA bracket, I think we are using the material stainless steel AISI 405. I need to check whether that material is available in this library. That should be here. 4110, this is 4110. I need 440 or 405. So you will get all the materials available here. If we just go down, titanium, yeah, titanium, this one also I need. Titanium 6, aluminum 4AV, so 4V, this one. If I just, you need to select, simply click on that and drag it, place it on top of here, stereo material, right? So you have placed this one here, right? After then also, because I am going to go for the 4 conditions, load conditions, also I apply different conditions. Now I want to check simultaneously, I will check with different materials also. For titanium also, and then there are lots of materials. You can select one by all the, if you want 4, 5, 6 materials. So it will give you a solution for all the materials, right? So as I select this one, titanium, now I will select one more material that we use for GA bracket, that we use in aviation industry. That I think that is stainless steel 440C. That should be here. QT 390 is there. 60, 440, 400, 405. Okay, HR. I think I need to go. Okay, so let me select any other material. Right now, I'm not finding that one. Yeah, this is one. This ES446. Weld, this one 430 and 4051. Yeah, so this material, I will just drag it and place it on the top. Stainless steel ASI 405. And then if we try other materials also, 2 more materials, how many meters you will use on this design. So it will give you solution for different materials for separately. So you can explore all the designs, all the solutions with different materials, and you can then compare which one is better, best, and you can select that one. Right. So these are the 2 materials that I have used for this one. Let me use this 2 one only right now because we don't have that much time. I will just use 2 material. And if you want to check what are the materials that I have used for this design, so you can go here, material selection. You can go here. We have a material model components. I need to go, I think, manufacturing. Yeah, you can see inside manufacturing, and then is additive. In additive, we will see here materials. Right. So here in materials, you will see these 2 materials that I have used. That's titanium 6 L 4V and stainless steel. So these 2 materials I have used for this particular design. Right. After then, you can go also. You can go pre-check. You can see whether you have followed all the conditions properly. If anything is missing, so it will show you here. Okay, one more thing, actually, the loads that I applied in the 4, I have not applied the load, so I will delete this one. Let me delete load 4. So it shows me that you have not applied a load in the load case number 4. Let me pre-check it once again. And now all the things are set. It's showing that some bodies are hidden, right? So I will unhide them. Obstacle geometry is here. So I will just unhide that. And now go pre-check and see it is showing me that all the setup is done. So I have followed all the conditions that I want to see in my design, and it will now give the outcome. So let me select here, click OK, and just go generate. Same way like we have done in the shape optimization, same way here generative design also, but here you will get different outcomes. In shape optimization you will get only one. Let me generate here. So it will take just a few minutes to get solution. Fine. Till then, as I was working on a shape optimization also, I will just go that solution till this particular solution will complete. Let me go for that. Where was that one? I will check whether my shape optimization complete or not. Yeah. So let me hide this generative design. So you can see here, this is the shape result of our shape optimization, right? As if just if you look on this design, if I go to the front side, and you will see if I go the mass ratio of this design shape optimizer, and you can see how it affects by using mass, how your design gets, how your shape gets, right? Let me go for the increase the mass up to this 0.4 mass ratio. And here, this particular shape I got, right, by using shape optimization. Okay, now I switch to again the shape optimization till my general design result will come, right? As you can see in shape optimization, this particular shape I got by applying some parameter, some condition, this one solution I got, right? You can select now from shape optimization, you can select the particular design. Okay, let me suppose I want as this particular shape I want, and I want to modify this shape, or I want to create a better design by using modifying this particular shape. Or suppose I want this one only, and I want to do some small changes on the design. So how I can do that? So you can see we can hide here. Let me hide this shape optimization, or let me hide this. Okay, this also. I want to keep this particular design only. So here's the one tool that we call promote. If you just types S first, after then you can just go promote tool, and you will get here promote. What I want actually, I want use this particular shape. That's a no organic shape. It looks like an organic shape, and you can see I want to follow that. I want to use this reference as a reference. Then I want to create a shape up from this particular optimized design. So here I will go here design workspace. I will click on the design workspace and select OK, and I got this kind of meshed design, right? This from optimization, we are getting this kind of solution. And then what we are doing, we are using this solution as a reference, right? And then we are creating a novel solution from this reference, or from this optimized shapes. Okay, as you can see how it time consuming it will be. Like you are just working on a particular design only, and then you are just modifying that and creating a solution. So but in general design we will get different solutions. So that's actually on a process. So once I will get a solution, you will see there will be different solution already, but here in the optimized shape we have only one. As I will use this reference, so you can see I want to hide, let me hide the body, and you can see this particular shape I can use as a reference, and I can create a my required design, or I can modify this particular design. Okay, so let me select here, or I will go here, right click, and then I will create new component because I want to use this particular optimized shape as a reference design, and I will create a same kind of design. So, but that's how we are creating by using optimized shape or by using optimization, process or simulation process. New component, and then let me give some name. Suppose I will use in a optimized shape and create new. Fine. So this will be a reference. So now I will select this particular face, select this one, and go for create sketch and use the front plane. Okay. So I will use this one. I will create from half of this one. Let's use a line tool for the reference purpose. One more thing. Okay, I will just undo this one. As I've already some sketches available there, I will go the sketch. Let me go the body. Where are that sketches? I will reference that. So these sketches are there already. So let's create sketch, those reference sketch by using circle tool. Right, one circle and then one more circle was there. This much, this circle. Fine. And the same way, like we have created the first profile, same way by after optimization, we are creating other profile and following that this reference optimized shape, right? And we are creating a this design. Let me go here from same way like we have done. Okay, actually this one I have not. Okay, that's this. Fine. You can just, if you want, you can drag it. And then I create a line here. So you can just follow this, you can use this reference. Like maybe you have seen some organic structure in the, some shaped or mesh or references, or maybe you in reverse engineering, how you are following the images of design, and then you are just using those as a reference, then creating a design. Same way here in optimized shape optimization, we are just, if you want to use a better design, so we can then use them as a reference and create a better design. Like this way, I will use and create as a reference. In the reverse engineering also, we do the same way. So there we just insert the image or insert the meshed design or organic shape, and then we follow the same way. In shape optimization also here in Fusion, we follow this kind of thing. Okay, let me select from here also. Select from one line from particular straight one part of this one, and I'll follow here. I'm just doing quickly this thing. Actually, it's a huge thing in shape optimization, but we don't have that much time, so maybe I'm just going quick to show you some result of this particular thing. Let's delete this one. And I will trim this thing. Okay, extra things. So just deleting these parts. Fine. So I got this particular shape here. Now I can extrude it. Let me extrude this part up to 20 or 25 or 50. We go isometric and select, drag it up to 50. Right. So this shape I got, you can see here, if I just hide this particular mesh it design, I got this particular part of from optimized shape. Right. And now what I can do, I can mirror this one. I can make a full wheel. Let me go for this mirror this particular part, one part, and mirror it according to, so that by using this face, not this face, by using this face, I will mirror it. Okay. Actually, it's far from. I will mirror it from this face. Or I will use the circular pattern of this one. Instead of that, let's go for circular pattern and create a 4 circular patterns there. Select this one and select the axis. Select the wrong axis around. Number of 4. No, actually there's some mistake here. I have deleted this part also. I need to keep this one. I will go here in the sketch, extrude. Otherwise I go to sketch here. Let's me go once again to this one. Body, sketch number, this sketch. Double click on that and go for the create sketch. The circle should be actually on the center. I have created this one here. Otherwise, I need to create here one reference plan around that axis. There was axis there. We can then make them combine. Otherwise, I need to create one by one all the components. So I have deleted by using this line. It should be from here to here. Let me now revolve or finish. I have not defined this particular sketch, so it should be actually using this origin, so that I can use these reference plans as a mirror and as well as axis for a revolve or a circular pattern. So it's some distance from here, from the origin. If I just annihilate this, you see here from origin is here and my circle is here. So I should have defined this circle on this particular origin, so that then I can use these reference plans for creating mirror as well as circle pattern. But they are far from this center right now, so I cannot use them. I need to create a separate, either I need to create an axis here or I need to create a reference plan here. Fine. So let me now go here. I will create a reference plan. I need to add one more thing here. So I go here, inspect, construct. So here's a create a offset plan and select the body. Let's hide sketch. Let me just complete this first one, hide the sketch. They are just disturbing this. Okay. And here you will see. Okay, so I'm doing one thing. I want to create a circular pattern, but what happened? I have created a circle. I have not defined a circle. So whenever you are creating profiles, whenever you are creating sketch, so first define that profile, make that fully defined with respect to origin. Okay, so that means you are you are just suspend degree of freedom of a particular profile with respect to origin. So what I have done, I have created profile, then I have not given the proper no, I can say constraints, and I have not defined that profile with respect to origin. So if I have created this profile on this origin, so I can now easily use this reference plans for mirror as well as circle pattern. I need to create now again mirror mid plan, and also I need to create a for the axis here. So it will take time. So we don't have that much time. So right now I got this part. I can just mirror it one part. If I otherwise I need to go once again. I need to select, here's one more option. If I just go sketch, right click on the sketch, and then you will see here we have a configure, or we have a redefined sketch plan, right? So in our in redefined sketch plan, we are just if I want this particular sketch should be in other plan, so we can then select that particular profile in other plan. It automatically all my design will go that particular plan, right? But right now I don't want to go in that particular topic. So I hope you got here one particular design or particular part from the shape optimization. So this was shape optimization. I got one component, right? And if you will go now generative design, and you will see if I go to solutions in generative design, we have a here, if I go explore designs, explore outcome, and you will see we may have different solutions. As I have this has been completed, and you can see now different outcomes will be there. Okay, so you can see we have here different outcomes, and we can compare them one by one. Like we have here outcome 1, 2, and 3 and 4. And it's just loading. Okay, see how many outcomes I got from applying some conditions, right? So these are some conditions that I applied, and I got this kind of loads. Now I can compare the result. So here are different ways to compare. If suppose I want a sort by this outcomes by using material, or by using generative model, or by using mass. So here you can sort that these solutions. Suppose I want sort by this by using mass. So I will select here mass, and you will see here for this particular study one, mass is 0.385 kg, right? And for the second one, the mass is 0.388 kg, right? In that way only you can see different. For here we have a least mass, so it is just recommending us that this solution is best, and also the strength will be there. You can just compare then the strength and properties also if you want to see. As now I'm just sorting this first according to mass, and you can see for first solution 0.385, and for the second one different that mass. Yes.
Sorry for the interruption.
Yes,
our
sir.
scheduled time is up to 9 o'clock because we are already in that late night. Many participants are struggling a lot, I think so.
Yeah, actually, I understand that. So that's why I went quickly to this. Otherwise, I had other plan to do. As we have started later, session. That's why there were some things that I have not touched yet. But anyway, so we got a solution. So I will just conclude these things. Just it will take 5 minutes.
You can take another 5 minutes, sir. No problem.
Yeah. So I will just explore these results only. I will then conclude the session.
Okay.
Okay, so here we can see the thumbnails of what outcome, and we have a properties, and you can see by using properties, you can see select if you want to compare, you can select tick on this one. Suppose I want to compare outcome number 1 and then outcome of second. So you can just compare, and then here we have a table view. In table view, you can check what are the materials that we have used. Suppose for the titanium, we have we have a recommendation 92 for 5%, and you can see different solution for this one. You will get with accordingly. You can select that. Suppose volume will be this one, mass will be this one, okay, and safety factor. So what are the conditions that you applied, and now the solutions that we are getting, and you can come, explore all the results one by one, and you can just select the which suits for you, and you can create that. You can use that particular design and for the manufacturing. So suppose I want this outcome solution one, I can select that one, right? And then you will see here, here's the option that this I click it here, and you will get that particular design. So then you will go to parametric modeling. You can go to the design workspace, and then if you want to change some of this design and some conditions on this design, right? So you can just use then these tools, or we have a create tools, and you can export that as a mesh, right, for the 3D printing, or you can use for a design from outcome. So you can go for a design from outcome, and you open the design workspace. So that particular then you can modify and use for the different export for the different manufacturing, whether milling process or 3D printing, right? So I need to come. No, actually, it's already 12. Sorry, 9:11. So I will now conclude the session. Uh, I know this is very advanced, so there are parts particular thing. At least learning this thing, it takes 1 month, right, to learn general design. But I try to some just touch all the topics, important topics in the general design, so that you will get some idea how we can use this general design in the Fusion 360. Right, that's it. Now I have missed the topics. I was thinking that I will talk about the G brackets or other things also, but we don't have that much time. So anyway, if we get any other chance, any other time, so I will try to cover those things. So with one more, I have shown you these things because software is, we have to wait a software to complete the process. So we cannot direct, go the fast. So I try to do that. It is taking in Fusion, it takes time to get the solutions, whether you are doing optimizing shape optimization, or whether you are doing general design. So it takes time. It goes cloud. So it takes time. So now I have just conclude this thing. I hope you got some idea how we can do in general design. I was trying, I was thinking that I will show you how we can then create a design, by using solid tools from this particular generative design. But we don't have that much time. So anyway, I hope you have learned something from this, these topics that I have covered. That's it. So I will now come to, no, I'm open for the questions if anybody is having.
Thank you, sir. Thank you, sir. Really, it was a nice presentation. And I understand that it is very difficult to cover the entire model within this 1.5 hours time. And what best we can able to cover within this 1.5 hours duration, that you covered excellent manner, sir. Really, it is a wonderful things, and people may get very good awareness about the Fusion 360. As many of the people don't understand about that advantage of using Fusion 360. You explained it nicely. Now they understand that why people are telling that it is an integrated software, can do all the design, manufacturing, and analysis process in a single software. So it is a nice presentation, sir. Also, your topic is very much aligned with our FDP theme, like lightweight structural component design. So I hope all the participants get useful information in this session. And now this session is open for questionnaire rounds. And participants, if you have any questions, please ask now. And I saw some questions in the chat box also, sir.
Yeah, just a minute. So actually, I have not looked. Okay. Okay. Somebody is asking me which one is more precise. Answer that Fusion. Actually,
before that also one question is there, sir.
Yeah. ANSYS is actually particularly we are using for the analyzing the design, right? But Fusion is it is integrated, or it's a package of different workspaces. So we can analyze, we can do the generative design, we can create a parametric design, or we can do the simulation, we can do the digital, I can say, form, or we can say, I've seen the different things we can do in the Fusion. But for analyzing process, ANSYS is good, but Fusion is vast software, so you can do lots of things in the Fusion. So I can say Fusion is best for if you want to explore different things, then the Fusion is best. If you want only stick on the analyzing, then ANSYS is best. Yes, actually, we have a customized material also. We can select a customized material in our design. In the Fusion, we have a lots of material available. If you see that those material, I think those material will be available in that particular library also. We have a lots, and also Fusion is monthly getting updated. So they are adding whatever things are missing. So they are adding those things. They are updating the software. So they are adding the material if that material is not updated. I understand. I understand. You are tired because you were from 5 o'clock. So, but I feel my thing that I have missed something. Anyway, so I hope something you have learned. So that's enough for me. If something I no, you got something from my side, but there was a plan for me, so I didn't complete those things also. Anyway, it was nice for me also.
One more question also there in the chat box, sir.
Can we change the material? Yeah, of course, we can change the material properties also. There's an option when we are applying the material. There are different ways. One is directly we are applying the material. Other is there we in the edit material we are just applying only those particular properties that we can do. We won't apply in the design. Right. So that's actually I have seen different whenever I was doing FDPs or webinars. So different people are asking me like that. We can do that, but there's a process to that. We have to apply in generative design or simulation. Only those two workspace we can apply. For other things, so we will just simply drag and place it. For other things we cannot change. On but two workspace we can change just generative design and simulation. In Fusion we can change it.
Thank you, sir. I guess no more questions. Yes. Okay. With this, we can conclude this session, sir. Really, it is a eye-opener session and very interesting session because when talk about this lightweight component design, the topology optimization is an important parameter. You just like that, you touched upon that thing and given elaborated information about the shape optimization and like topology optimization. Really, it is a useful presentation, sir. And I really feel that the same kind of understanding level is there for all the participants for this particular session. So with this we can conclude this session, sir. So tomorrow we have two interesting sessions. One with Dr. A.K. Lakshmi Narayanan going to give you a live demo about 3D printing workflow and the post-processing insight in the first session. Second session, we have our own faculty, Dr. S. Prakash, going to give you a parametric design and topology optimization methods. So I request that participants please join on time so that we can able to proceed that FDP proceedings in a smooth manner. And today our guest was waiting so long in that portal. People are joining only after 6:10 p.m. Nearly after 10 minutes the waiting period only we are going to start the FDP. Tomorrow, I guess, I hope all that participants will join before 6 p.m. Thank you for your cooperation. Thank you, sir. Thank you all. With this, we can conclude today's session. Prakash, stop the record.
Okay, sir. Done, sir. Thank you, sir.